So here is my video of the pendulum and the collision. Yep. And here's some extra outtakes because I did like a million trials. So here's some bonus footage, but today we're going to be finding the mu or the mu, and here is how I did it. So these are the different measurements that I took for the experiment, and a lot of them I had to convert from inches to centimeters. So that was one issue, but other than that, these are all my measurements. And here are the different concepts and theorems that I use. First is the conservation of energy. We can use that to find the difference between the potential energy and the kinetic energy right before the pendulum drops, because that is the area where there is no work or frictional force, so we can use it there. Then we have the conservation of momentum, which we can use because it is an inelastic collision. And next we have some kinematics equations, and finally we get to use Newton's second law to determine the force, which will help us determine the coefficient. And then next we have the free body diagram of the box right after the collision, so that's that. And then here are the energy diagrams, which basically represent the potential energy, work, and kinetic energy at different instances. And here is a graph at the top, which basically demonstrates the pendulum or the bag of sugar right before it comes into collision and contact. And because we can use a conservation of mechanical energy, we can calculate and set the potential energy initially equal to the final kinetic energy and the final potential energy, which I do here. But before I can do that, I'm sure to do some dimensional analysis to make sure my units are in correct SI units. And then finally, we need to use that calculation of velocity that we get from our final mechanical energy calculation using the kinetic energy. And once we use that, we can use the conservation of momentum. Since this is an inelastic collision, we can use a conservation of momentum, and thus by setting both equal, we can find the calculation. But when this collision is happening, we see that the masses combine, which includes the mass of the sugar as well as the mass of the box, which is why we have an uppercase and lowercase m. Next, we can use the kinematic equation to determine the acceleration, and we need this acceleration in order to do force calculations. So after that, we can plug in the acceleration that we got from the kinematic equations into the force equals mass times acceleration, or Newton's second law. And from there, once we get the frictional force calculated, we can plug that into the same equation where F is equal to the mu times the normal force. And that's how we find the coefficient. So finally, with some sources of error could be on measuring mechanisms, because I was using inches rather than centimeters and meters. So that conversion could be with less precise data because of significant figures. And then next, another error is human error, because I did multiple trials. I had to reset and relocate to the specific location where the pendulum can drop.